what is a black sun? In the paper, Life Under a Black Sun, authors Tomasz Opartny, Lucas Richterich, and Pavel Bakula describe a scenario whereby a planet is drawn into orbit not by a star, but by a black hole. The study by this group of Czech scientists focuses specifically on a situation whereby a planet would be found in orbit around a fast-rotating Kerr black hole, as seen in Interstellar. You know, that movie where Matthew McConaughey's daughter gets trapped behind a wardrobe in another galaxy or something. I have no idea. Maybe it was Narnia. Anyway, the situation depicted in Christopher Nolan's movie is not a fictional construct. There may be black holes with planetary systems out there in the universe. Our entire Milky Way is thought to orbit one giant black hole, possibly two, which lie at the center of our galaxy. If a black hole were small and stable enough, a planet could easily fall into orbit around it. And if it did, life on this world would be very bizarre indeed. Opartny, Richterich, and Bakula have estimated that a total of 900 watts of usable power could be squeezed out of the temperature difference in place between a black hole sun and the CMB for use on one of its orbiting planets. However, the cosmic background radiation of the universe was much warmer during the universe's early years. Physicist and cosmologist Avi Loeb of Harvard University has famously claimed that when the universe was only 15 million years old, the CMB would have been 27 Celsius, also known as a British heat wave. At this temperature, liquid water could have existed on a planet orbiting a black hole, offering further temptation for life to get its butt in gear and spring into existence. Unfortunately, given the time it would take a black hole to clear its surroundings and cool the heck down, 15 million years is cutting it more than a little fine. And this is before we consider how little time life would have had to evolve into a multicellular organism, let alone an advanced one capable of harnessing enough power to forge a civilization. If life was to have formed on a planet in orbit around a rotating Kerr black hole, said black hole would have to be supermassive in size. Displaying further love for Interstellar, the Czech scientists cite the example of Miller's planet, which McConaughey's spacefaring research team came to discover in orbit around a giant spinning black hole called Gargantua. In the movie, Miller's planet is a water world, like that Kevin Costner movie, Robin Hood, Prince of Thieves. But in real life, if such a planet existed at such close orbit to a rotating, supermassive black hole, that water would be replaced by tidal waves of molten aluminum. If a planet was found orbiting a specific type of black hole, there is a chance that strange life forms could be found upon it. The second law of thermodynamics, which I will now pretend to understand, claims that life requires a temperature imbalance to provide a source of usable energy. On Earth, we have the difference between the sun and the coldness of space. In a hot pocket, you have the searing lava filling in contrast to the relatively temperate climes of your stomach. But for a planet in orbit around a black sun, this energy discrepancy would be completely reversed. Black holes, which have stopped absorbing mass, have a temperature so close to zero, they may as well be spooning it. If it was old enough and it had already eaten all the matter in its near vicinity, the black hole's static status would enable it to act as a frigidly cold sun, with any orbiting planets safe from devourment if they are far enough away. The temperature discrepancy needed to promote the flourishing of life would be provided by the relatively warm climate provided by the universe's cosmic background radiation. Cosmic background radiation, or CMB to its pals, is the residual heat left over from the Big Bang. At present, the CMB makes our universe run at a temperature of around minus 270 Celsius. Compared to Earth, this is darn chilly. But compared to the temperature of a black hole sun, the cosmic background radiation of the universe is pretty toasty. This temperature difference would create a hot sky, which would warm the planet. And while this sky isn't warm enough to cover the energy needs of an advanced civilization, it would be enough to promote the existence of life. Although, things might have been a little different a few billion years ago. According to Tomasz Opartny, a world in a similar situation to Miller's planet in the movie Interstellar would be heated to nearly 900 degrees Celsius. This heat is caused by the time dilation in effect, which itself is caused by the black hole's gravitational pull in accordance with the law of general relativity. In the movie, 1 hour on Miller's planet is the equivalent of 7 years off it. Personally, I'd rather wait 7 years on the ship. Even 1 short hour is a heck of a long time to spend in the company of Anne Hathaway boring everyone to shreds. Based on the simple math of 24 hours a day times 365 days a year times 7 years, we get a time dilation factor of around 60,000. This is a problem, because according to the paper, the energy of light is proportional to its frequency, and when the light from the cosmic background radiation hits Miller's planet, the time dilation increases this frequency, hence the 900 Celsius temperature. At this level of scorchiness, molten aluminum waves would cover the planet's surface, And even if you own some kind of protective, heat-resistant space burqa, you'd still have to deal with the huge amounts of UV radiation emitted by a giant black hole sun. And having personally spent a great deal of time licking isotopes and rolling around in radioactive ooze, I can tell you that radiation ain't all that. If the planet was a little further out, though, then the theory by the Czechs isn't entirely wrecked. Opatrny, Richterich, and Bacala conclude their paper by speculating that if a black hole like Gargantua were found, an Earth-like world suited to life may exist in a more distant orbit.